press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next problem in exercise 1.5. So up to third main we finish up. Fourth main problems. Observe here. If u is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to 2, 4, 6, 8. B is equal to 2, 3, 5, 7. A, B are no doubt. They are subsets of U. Okay. What he asks, we will select. Verify that first one. A union B whole dash is equal to A dash intersection B dash. A union B whole dash is equal to what? A dash intersection B dash. Second one, A intersection B whole dash is equal to A dash union B dash. A dash union B dash. A intersection B whole dash. A intersection B whole dash is equal to what? A dash union B dash. Okay. First one, what I do? Firstly, I find A union B. A union B. Before that, I write here only A dash is equal to U minus A. We discussed already in the previous class. Yes, na? U minus A. 1 is present in A? No. 1. 2 is present. 3 is not present. 4 is present. 5 is not present. 6 is present. 7 is not present. 8 is present. 9 is not present. This is nothing but what? This is nothing but A dash. So then we write B dash also. B dash. Check out. 1 is present? No. 2 is present. 3 is present. 4? No. 5 is present. 6? No. 7 is present. 8? No. 9? No. A dash and B dash. Okay. A union B. Everyone know A union B. So 2, 3, 4, 5, 6, 7, 8. Correct? 2, 3, 4, 5, 6, 7, 8. So A union B whole dash. A union B whole dash. A union B whole dash. U minus of A union B. Comparing these two results. Okay na? So write it. 1 is present? No. Right. 2s, 3s, 4s, 5, 6, 7, 8, 9. That implies A union B whole dash. A union B whole dash is what? 1, 9. A union B whole dash. A union B whole dash is what? 1, 9. LHS is over. Call it as 1. Similarly, I write here. Similarly, we find RHS. RHS is what? A dash intersection B dash. Correct? A dash intersection B dash. I write once again these two sets. Okay, that is equal to 1, 3, 5, 7, 9. Intersection 1, 4, 6, 8, 9. 1, 4, 6, 8, 9. Okay. So common elements, what are those elements? See the problem. 1 is present in both sides. Yes. 3, no. 5, no. 7, no. 9, yes. 1, 9. This is what? A dash intersection B dash. Call it as 2. See the result. See the result 1 and 2 carefully. See the result. See the result. See the result 1 and 2 carefully. Okay, from 1 and 2. From 1 and 2. What? LHS, RHS is same. So from 1 and 2, that implies A union B, A union B whole dash is equal to what? A dash intersection B dash. A union B, A union B whole dash. Very, very important. This is a property of a complement set. We will discuss in the property. Okay. A union B whole dash is equal to what? A dash intersection B dash. First one is over. First one is over. We will see the second one. Second one, LHS observe here, A intersection B. Firstly, we find A intersection B. A intersection B, common elements, 2 is present, 4, no, 6, no, 8, no, only one element. So A intersection B whole dash, A intersection B whole dash, nothing but U minus of A intersection B. Only one element we left out. We write all the elements of the universal set. 1, 3, 4, 5, 6, 7, 8, 9. Call it as 1. Call it as 1. So then, RHS is what? A dash union B dash. That is equal to 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Union 1, 4, 6, 8, 9. Union 1, 4, 6, 8, 9. So that is equal to 1, 3, 4, 5, 6, 7, 8, 9. Call it as 2. So observe these two results. Observe these two results. From 1 and 2, observe carefully. RHS is what? Same. From 1 and 2, from 1 and 2, A intersection B whole dash is equal to what? A dash union B dash. A intersection B, A intersection B whole dash, A intersection B whole dash is equal to what? A dash union B dash. So these two are properties of a complement set. So particular name is there, De Morgan's law. These we call it as what? De Morgan's law. We will see in the later. When we discuss the properties, we will write once again. So A union B whole dash. A union B whole dash is equal to, we prove that, A dash intersection B dash. A intersection B whole dash. A intersection B whole dash is equal to what? A dash union B dash. Observe the problem very carefully, and this is very, very important for 3 mark. This is very important for 3 mark questions. Understand? See the problem carefully. Next problem. Next problem. See that. Fifth main. Draw appropriate Venn diagram. Very interesting concept. Draw appropriate Venn diagram for each of the following. Each of the following. So we will solve one by one problem. First problem. A union B whole dash. A union B whole dash. So draw the appropriate Venn diagram. So correct the Venn diagram for what? A union B whole dash. Okay. See the problem first. So okay, firstly I draw A union B. Already I explained universal set. This is what? Universal set. This is what? A union B. For that, A union B. This is what? A union B. This is first set, A set, and this is B set. A union B. Correct? Correct na? A union B. Since A union B whole dash is nothing but U minus of A union B. Correct? U minus of what? A union B. So for that, I write one more diagram. So we write here A union B whole dash. This is the reason. U minus of A union B means we left out all these values. U minus of A union B. This is what? See the diagram. This is what? A union. This is what? Universal set. A union B whole dash. So what he want? He want A union B whole dash. A union B whole dash. This is what? A set, B set. This complete reason. See the diagram very carefully. A union B. A union B whole dash. First one is over. Understand? Firstly I write A union B. Then I write A union B whole dash. Second problem. Second problem, A intersection B. A intersection B whole dash. A intersection B whole dash. For that, what we do? We write A intersection B first. This is what A and this is what B and this is universal set. This is what A intersection B. A intersection B. A intersection B. So what we want? We want A intersection B whole dash. Since A intersection B whole dash is nothing but U minus of A intersection B. All the reason except this value. Except this value. We draw one more. So what we write here? We write A intersection B whole dash. Okay na? A, this is what? A set, B set. All the reason. Only we left these values. Correct na? Once again, so circle is over. Already, once again I draw the circle. This is what, observe, this is what A intersection B whole dash. A intersection B whole dash. A intersection B whole dash. This diagram is A union B. A union B whole dash. And this diagram is A intersection B whole dash. A intersection B whole dash. Carefully observe these two diagrams. Firstly, A union B whole dash, the reason when we write in the by using Venn diagram. Here also we write A intersection B whole dash by using Venn diagram. Third problem. Right here only. Problem number third. Third one, what he has A dash intersection B dash. A dash intersection B dash. What I do, I use this property. Just to the previous problem we solved. I use that property. Since A union B whole dash is equal to A dash intersection B dash, that implies, we draw, this is the enough. If you want A dash intersection B dash, so we write A union B whole dash, this is exactly equal to what? A dash intersection B dash. For third problem, we write this diagram and write, since A union B whole dash is equal to what? A dash intersection B dash, that's why A union B whole dash is the thing, but A dash intersection B dash. Third problem, same diagram. Fourth problem. What he asks? Fourth one. A dash union B dash. A dash union B dash. Since A intersection B whole dash is equal to A dash union B dash, that implies, this is diagram is enough. A dash union B dash. A dash union B dash. So first problem is over, second one is over, third one is over, fourth one is over. So 4 questions are given. Draw the appropriate Venn diagram for each of the following. See the problems very carefully. See once again the problem very carefully. All 4 problems are over. Okay now? So understand? So it is very important concept for 3 mark. So it may ask in the examination, draw the appropriate Venn diagram for any one of question. If given this question, same diagram. If given this question, same diagram, by using the properties of De Morgan's law. Properties of De Morgan's law. Clear? Clear? Once again you observe the diagram. So this is very important. Okay, we continue the next problem. Next problem, 6th May, an exercise 1.5. Let U be the set of all triangles in a plane. U be the set of all triangles. U be the set of all triangles in a plane. Full stop. If A is the set of all triangles with at least one angle. at least one angle different from 60 degree. One angle, see the problem, with at least A is the set of all triangles with at least one angle different from 60 degree, comma, what is, very easy question, what is A dash? What is A dash? What is A dash? You be the set of all triangles, rectangle triangles, equilateral triangles, scalene triangles, all triangles are present. Isosceles triangles are present. A be the set of all triangles with at least one angle different from 60 degree means among three angles, if two angles 60 degree, no problem. All three angles are 60 are not present in A, are not in present in A. What is the A dash means? No doubt answer. A dash is set of all equilateral triangles. Correct now? All angle is 60 degree. A dash is nothing but what? Set of all but equilateral triangles. Next question. Seventh May, fill in the blank to make each of the following a true statement. We have to fill. So first question, first one, A union A dash, A union A dash. So in a universal set, so example, let U is equal to A, B, C, D, four elements are present. Okay, for simple example, A is equal to what? A, C. A is equal to what? A, C. What about A dash? A dash is nothing but B, D. A dash is nothing but what? B comma D. So then A union A dash, you combine these two, A, B, C, D, comparing these two sets. So that implies A union A dash is always nothing but what? Universal set. A union A dash is always equal to what? Universal set. Clear? Clear the concept? Okay. Next question. Second question. A intersection A dash. Okay. Same set I'll take A intersection A dash. So A union A dash is over. So U and AB. So then A intersection A dash, it is always empty because since A and A dash are disjoint sets. So A intersection A dash is what? Is what? Empty set. Understand? Third question. Third one. Pi dash intersection A. Pi dash intersection A. Okay. For that pi dash intersection A. So pi is an empty set. So that is nothing but pi dash. Pi dash is nothing but what? Universal set. Correct now? Pi dash is nothing but what? Universal set. So hagadre pi dash intersection A. Pi dash intersection. Universal set means what? A, B, C. C, D. Pi dash intersection A. Pi dash is what? A, B, C, D intersection A comma C. So pi dash intersection A is what? A comma C. So that is always pi dash intersection A is always equal to what? A. So answer is what? Answer is A. Pi dash intersection A is always equal to A. Fourth question. U dash intersection A is very important. U dash intersection A. Okay. See, observe here. U dash is nothing but what? Empty set. U dash is nothing but what? Empty set. So U dash intersection A, empty set intersection A comma C. So that is nothing but what? Empty set. That is nothing but what? Empty set. These are all properties. Very important concepts. Very important concept. A union A dash is nothing but universal set. A intersection A dash is nothing but empty set. Pi dash intersection A is nothing but A, and U dash intersection A is nothing but what? Empty set. So this completes the exercise 1.5. This completes exercise 1.5. Means we finish up union of two sets, intersection of two sets, difference of two sets, complement of a set. 4 concepts we finish up. We discuss the properties one by one. Union, intersection, okay, and complement of a sets. So see the properties. 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 First concept. Union. Properties regarding union of two sets. Under that, first one. Observe here. A union B is always equal to B union B. So for that I write an example. A is equal to 1 comma 2 and B is equal to 2 comma 3. Find A union B. A union B is what? 1, 2, 3. B union A. B union A is what? Again it is 1, 2, 3. Yes, now 1, 2, 3, 1, 2, 3. Seeing this result, A union B is equal to what? B union A. This is first property on union of two sets. A union B is equal to B union. This property we call it as commutative law. This property we call it as what? Commutative law. A union B is equal to B union A. Second one. A union B of union C is always equal to A union of B union C. Observe here we tag these two, A and B. Here we tag B and C. For that we take one more example. So observe here, A is AB and C are right. C is 3 comma 4. Okay, C is 3 comma 4. Firstly I find A union B. A union B is what? A union B is 1, 2, 3. So then A union B union C. A union B union C. 1, 2, 3. Union 3, 4. So answer is 1, 2, 3, 4. Correct now? A union B of union C. RHS. Firstly we find B union C. B union C. 2, 3, 4. Then A union of B union C. A union of B union C. Combining these two results. So again it is 1, 2, 3, 4. See the result, both the result. These two are what? Same. RHS is same. So that implies A union B of union C, A union B of union C is always equal to A union of B union C. This property we call it as associative law. First one is commutative law, second one is associative law. Third property, A union empty set is always equal to A. Correct now? A union empty set. Empty means no elements. It is always equal to A. Fourth property, A union A is always equal to what? A. Correct? A union A is always equal to A. Fifth property, A union universal set is always equal to what? U. A union universal set. A union universal set is always equal to U. These are all the properties for union of what? Two sets. Similarly, we discussion intersection of two sets. Union is over. Intersection of two sets. Second one, intersection of two sets. First property, A intersection B is always equal to B intersection A. See that A set, it has some elements A, B, C, A, B, and B set, it has some element B, comma, C. Find A intersection B. A intersection B is what? B. Find B intersection A. B intersection A is what? B. Observe these two results. Carefully. A intersection B is equal to what? B intersection A. This property is called commutative property. Second one, A intersection B of intersection C is always equal to A intersection of B intersection C. A intersection B of intersection C is always equal to A intersection B of intersection C. Associative property. We will solve one example. A is equal to A comma B. B is equal to B comma C. C is equal to C comma D. C comma A. Okay. Firstly, I find A intersection B. A intersection B common element is what? B. Then A intersection B of intersection C. So combining these two result, empty set, has no elements. Next, B intersection C. First I find B intersection C is what? C. Then A intersection of B intersection C. Combining these two set, so no common elements. That is what? Empty set. See the result of RHS. Empty. So one more very important property, associative property. A intersection B of intersection C is equal to A intersection of B intersection C. Next property. Next, third property is A intersection empty set. What is always empty? Empty means no elements. A intersection empty means no common elements. No common element means empty set. Fourth property. A intersection A is always equal to what? A itself. A intersection A is always equal to A. Fifth property. A intersection universal set is always equal to what? A. A intersection universal set is always equal to A. So sixth property, distributive law. Very important property. A intersection of B union C. Distributive law. We call it as distributive law. A intersection of B union C. A intersection B union A intersection C. This is first one. intersection over union. Intersection over union. A intersection of B union C. Observe LHS very carefully. Intersection over union. A intersection of B union C is always equal to what? A intersection B union A intersection C. Second one, A union of B intersection C is always equal to union over intersection A union B intersection A union C. Intersection A union C. This is intersection over union and this is union over intersection. Better we solve one problem regarding distributive law. Then only we perfect the concept. For that I take a simple set. So what I take, A is equal to 2 elements 1 comma 2, B is equal to 2 elements 2 comma 3, C is equal to 3 comma 2 comma 4, 3 elements 3 comma 2 comma 4. Firstly, so any one property I discuss. First property I discuss. Firstly I find B union C. B union C. Combining these two. 2, 3, 4. Correct na? B union C. Then A intersection of B union C means 1 comma 2 intersection of 2, 3, 4. So common element is what? 2. Call it as 1. Call it as 1. Nextly RHS. RHS A intersection B. First we find A intersection B. A intersection B. Common element is what? 2. A intersection C. Common element is what? 2. Only 2. Then A intersection B. A intersection B union A intersection C. It is 2. Call it as 2. From, right here, from 1 and 2, from 1 and 2, observe carefully, from 1 and 2, RHS is what? RHS is same, that implies A intersection of B union C is always equal to A intersection B union A intersection C. This is what? Distributive law. Intersection over union. Firstly is intersection, second one is union. Intersection over union. If you want, we solve second one also, no problem. First one is over. Correct na? First one is over. Second one, for same example, B intersection C, first I find B intersection. Common elements are what? 2 is present, 3 is present. A union of B intersection C. 1, 2, union 2, 3. 1, 2, 3. 1, 2, 3. So call it as 1. Second RHS, A union B. A union B. 1, 2, 3. Correct now? Next, A union C. 1, 2, 3, 4. Then A union B intersection A union C. Common elements. Common elements are 1, 2, 3. Call it as 2. See, observe here, from 1 and 2, from 1 and 2, observe carefully, A union of B intersection C is equal to A union B intersection A union C. So these two are very, very important properties. A union of B intersection C is equal to what? A union B intersection A union C. It may ask 3-mark questions in your examination. Verify distributive law. Union over intersection. Union over intersection or intersection over union. Clear? See the concept very carefully. These two properties we call it as what? Distributive law. Distributive law. These completes the properties of what? Union and intersection. We will see the properties of what? Complement of a set. So nextly, third one, properties of complement set. That particularly first property. Properties of complement set. First property, A union A dash is equal to U. A union A dash, A union A dash is equal to U. See that one example I write. U is equal to some elements A, B, C, D. A I write A comma C. A dash, no problem. A dash is what? B comma D. So A union A dash, nothing but what? Just now we discuss. Fill in the blanks. A union A dash, nothing but what? Universal set. Second property, second one, A intersection A dash is always equal to empty set. Correct now? So you observe here A intersection A dash is nothing but empty set because A and A dash are what? Disjoint. A and A dash are disjoint sets. A and A dash are disjoint sets. Third one, third property, A dash whole dash is equal to A. A dash whole dash, A dash whole dash is equal to A. So observe here, A dash whole dash, nothing but what? A comma C. So that is equal to A. We solve in the problem also. A dash whole dash is equal to what? A. Fourth property. Fourth property, pi dash, empty dash is nothing but what? Universal set. See, empty dash U minus empty. Empty has no element. Empty has no element means universal set. Fifth property, universal dash is nothing but what? Empty. Universal dash. U minus U is nothing but what? Empty set. U minus U is nothing but what? Empty set. Sixth property, this is very important. A union B whole dash, A dash intersection B dash, A intersection B whole dash, A dash union B dash, A union B, observe carefully, A union B whole dash, A dash intersection B dash, A intersection B whole dash, A dash union B dash. These laws are called De Morgan's. We solve, just now we solve the problems. Yes, na? De Morgan's law. De Morgan's law says that, very important property, A union B whole dash is equal to what? A dash intersection B dash. A intersection B whole dash is equal to what? A dash union B dash. These two properties are called De Morgan's law. So these are all the properties of what? Complement of a set. Complement of a set. Okay. So we stop up to this. We continue the remaining concept in next class. Thank you.